So here we will be converting a number to a binary, a floating number to a binary number. And we will be using this website as to verify what you are doing, okay? And the idea here is, if I take an example, I'll see if I can describe everything in this video here. If you have a number, let's take a simple example of say 2.5 is a very simple example, but we can go with it. Convert this left hand side to binary number. Convert to a binary number the way you regularly do. So that will be 1 0. All right, point. And here this point, this phi, you need to multiply by 2. All right, you need to keep multiplying by 2. I'll show you some examples how it's to be done. So phi times 2 is basically 0.5, okay? So it's 1.0. Because you saw 1 here, that goes 1 here. And your remaining is, the remaining, you need to take the remaining fraction. Remaining fraction here in this case is 0.0, right? Times 2 again. That is going to be 0, right? So no matter how much you do, it's going to be zeros, all zeros, okay? So it's all 0, doesn't matter how many number zeros you have. So if you see this format is we need to convert this. This format is equivalent to 2 times 2 power 1, right? 2 power 0. So now I can change that to 1 0. It doesn't matter how many zeros I have. 2 power 1, isn't it? We are now binary. We are in the binary, so it's 2 power 0. And I have 2 times 2 to the power 1. And what happens here is this, I'm going to write it in red. This 1 you need to add to 127 plus 1. That is going to be 128. So 128 is your exponent. In binary, it is 1 0 0 0 0 0 0 0. And you have the rest, you have to fill it in, right? So the mantissa is 23 bits. This is 8 bits. We're going to represent. And we have sign bit, which is 1, is 0 here, right? So this one, you need to fill it up in 23 bits, which is equivalent to what? 0 1 0 0 0 0 0 0 0 0 0 0. We have 12, 16, 20, 23. So if you want to convert 2.5 into binary number, this is the actual. So let's go here and check it out. Remember 128, right? So 2.5, first is a sign bit. Next we have 8 bits. Next we have 8 bits, which is 128, the exponent, right? Then the mantissa starts from here. 0 1, it's all zeros, right? So that's what we have, 0 1. You see that? It's all 0 1. Let's take another example, okay? Let's take another example. It's not a big deal. Let's take 1.75, another example. Or we can see, let's take a 4.75, all right? So 4.75, like I said, you need to convert this 4 to binary, like the way you usually do. 100 dot. We have 0.75. 0.75 times 2 is 1.5, right? So we got 1, so write 1. And we left is 0.5 times 2. then we get 1.0. We got 1, so write 1, and we got 0, so 0.0 times 2, no matter how many times you do, is going to be 0, so it's all zeros, right? And I said this has to be in the format 1 point. So how many points you need to push to the left? Is 1, 2, right? 0, 0, 1, 1, 0, 0, 0, and it's all zeros, okay? We'll fill it up. Times 2 power, we pushed to 2 times, right? 1 and 2. So it's 2 power 2. And I said in the beginning, we need to add this 2 to the exponent. So 2 plus 127 is 129. And 129 in 8-bit is 1000001. And then we have this entire thing is the mantissa. This is the mantissa. All right. All right. So here, so that is one way of doing. Let's do one more. We have lots of time to do. Let's take a simple example, another simple example. Let's see what I have in the 2.64. I have 2.6. This is a little bit tricky. I have 2.64, so I'm going to show it to you. Okay, this is a little tricky. So 2.64. We need to convert that to binary, so it's going to be 1 0, and 0.64 we need to convert to binary, right? So times 2, that is 1.28. So we need to write 1 and drop times 2. That will be, how much is that? 0.56. So we have 0 now, so we need to write 0 there. All right. So 0.56 times 2 is 1.12, right? So we have 0, 1 here, so we need to write 1 there. So we're left with 0.12 times 2, how much is that? That's going to be 0.24. So we got again 0 here. We need to write 0 there. So 0.24 times 2, how much is that? Maybe I should write down here. Don't worry, wait. Times 2 is 0.48. So 0.48, if you, because you got 0, you got to put 0 there. So times 2, 0.96. 0.96, we got 0 there, so it has to be 0 there. Again, times 2 is 1.92, right? So we got 1. We got 1 now, isn't it? So we got to put 1 there. Times 2. We should only consider 92. Remember that, right? So it's 1.84. So we got 1 again. So we have 0.84. 0.84 is 1.68. So 1 again. So you need to do this to fill up those 23 bits, right? 23 times you need to go. But let's leave it at this, and I'll show you this one. No matter what, is 2 times 0. Remember, I missed a lot of calculations because you got the gist of the story, so you have to go and fill it up. But now I can write this as 1.010100 0111 times 2 power 1. So 2 power 1, I said 1 plus 127, which is 128. So the exponent is same, and then the rest, if you see, it should match. All right, so let's go. The sign bit of course is 0, and if you go to their website, what was the value we said? 2.64. Let's plug it in. 2.64. So 2.64 sign bit, and 8 bits is exponent, and the mantissa starts from there. If you see, okay, let me do it one more time. I did something there. So exponent is 4, that, and from here the mantissa starts, right? It goes on for 23 bits. So if you compare that with what you have, let's compare. I'm trying to compare. There it is. So you see 0, 1. We need to compare from here. 0, 1. You have 0, 1, 0, 1 again, 0, 1 again. Then you have 3 zeros. You see that we have 3 zeros. That's what we have. 3 zeros. We have 3 ones, and it goes on. Remember, we stopped. Oh, sorry. We stopped at here. But if you continue, you'll have the same thing. So the idea here is you have to convert to, if you take this binary number, the left hand side convert to binary number the way you do, and the right hand side after the power point floating, we need to multiply into 2. If you get a 1, you write 1. If you get a 0, you write a 0. You keep doing it for quite some time, and then you stop it, and you see, so then you represent like this, right? If you have a number of like that, you need to convert that into 1.0 times 2 power 2 in this case. So it always has to be in this format. So you can drop this 1. We don't store that 1 because we know that's going to be 1. So that is how it has to be done. Okay. Thank you.